This is mathheals.com, where you can find more links to YouTube math videos. And let's take a look at polar equations and graphs. And let's first refresh our memory on some of our formulas we had. We had x is equal to r cosine theta. Y is equal to r sine theta. Along with those, we had cosine theta is equal to x over r. Sine theta is equal to y over r. Tangent theta is equal to y over x. R squared is equal to x squared plus y squared. And r is equal to square root of x squared plus y squared. And let's look at our first problem. It says transform each polar equation to an equation rectangular, then identify and graph the equation. Now here, we know what r is. That's equal to the square root of x squared plus y squared. So I can go to replace r with that. And now I could square both sides. Now when I square this, the square root and the second power cancel, and we're left with x squared plus y squared is equal to 25. Now this is a circle with a center at the origin with a radius equal to the square root of this number. So square root of 25 gives us 5. So our graph would be circle of radius 5 with the origin, or with the origin being our center of a circle. Now r is equal to 5. That would tell us that we don't know what the angle is. The angle can be anything, but the distance is 5. So that's why it's a circle when you think about it in that sense. Let's see, on this one we had theta is equal to pi over 4. Now I don't have a theta by itself in here, but I do have tangent theta is equal to y over x. So what I can do is I can take tangent theta both sides. Now tangent theta from our formula is equal to y over x. Tangent pi over 4. If I look at pi over 4 in my unit circle, my x value and my y value are both square root of 2 over 2. So tangent is y over x. So square root of 2 over 2 all over square root of 2 over 2 is 1. Multiply both sides by x, and we get y is equal to x. Now graph-wise, y is equal to x is a line passing through the origin like that. Number 3, we have r cosine theta is equal to 3. Now up above, r cosine theta is equal to x. So this becomes x is equal to 3, which is a line. Specifically, it's a vertical line at 3. So I'll go to graph it, and that would be our answer. For a fourth one here, we've got r sine theta is equal to negative 5. And up above, r sine theta is y. So we get y is equal to negative 5. Means I'll have a horizontal line at negative 5. Which would look like that. Now this one, we have r is equal to 3 sine theta. Well, the only sine theta we have in our formulas, besides this one, which doesn't help us, but the only sine theta is this one up here and has an r in front of it. Well, we could go through and multiply everything by r to begin with. So r times r is, actually let me put the steps there. R times r is equal to r times 3 sine theta. So we get r squared is equal to 3r sine theta. Now r squared is x squared plus y squared. And r sine theta is equal to y. Well, we want to get everything over one side and 0 on the other for this particular problem. So we've got x squared plus y squared minus 3y equals 0. And we want to complete the square on the y's. So we'll take the number before our y, which is negative 3, multiplied by half and squared. It's always by half, it's always squared. Negative 3 times half is negative 3 halves, and negative 3 halves squared is 9/4. And we'll add that to both sides. So we've got x squared plus y squared minus 3y plus 9/4 equals 0 plus 9/4. Now the x squared, I can rewrite that as x minus 0 squared. I can factor the y's here. This factors as y minus 3 halves squared equals 9/4. Now this is in standard form now for a circle. And h is whatever number's here. It's opposite sign, but opposite of 0. The 0 doesn't have a sign, so it's just 0. And here's k, and it's opposite sign. So k would be equal to a positive 3 halves. And this is r, and we just take square root of it. So square root of 9/4 gives us 3 halves. Now let me graph it over here. We got a circle. Our center is HK, which is 0, 3 halves. Of course, that's our radius. So 0 and 3 halves will be right there. So that's our center. Radius is 3 halves, so I'll go out a distance of 3 halves and go all the way around. That's a circle. Let me save this. This is, what is this? Polar equations and graphs. So trig, polar equations and graphs, page 01.pdf. There we go. And let's start a new page and look at the next problem. We got r secant theta is equal to 6. Same instructions. Want to transform it to rectangular, identify, and graph it. Well, secant is 1 over cosine. So this becomes r over cosine theta is equal to 6. Now I want to get rid of the fraction, so I'll multiply both sides by cosine theta. And we get r is equal to 6 cosine theta. Well, the only formula we have for cosine that we can use is one with an r in front of it. So we'll multiply both sides by r. So we've got r times r and r times 6 cosine. So we got r squared is equal to 6r cosine theta. Now r squared on the left side we can rewrite as x squared plus y squared. And the r cosine theta on the right side is x. Well, this is another circle, so we have to put it in our standard form. So I take the 6x over. So we got x squared minus 6x plus y squared is equal to 0. We want to complete the square on the x's, so we'll take the number before our x, which is negative 6, multiply it by half and square it. Negative 6 times a half is negative 3, and negative 3 squared gives us 9. And we'll add that to both sides. Now that we can factor this, this factors as x minus 3 squared. Remember the trick for that. Whatever number is right here, sign included right before you square it, is always what goes right here. And y squared we can rewrite as y minus 0 squared. And 0 plus 9 is 9. Now this is in standard form, so this will be our h, and it'll be opposite sign, so it'll be 3. This is our k. It'll be opposite sign, but 0 doesn't have an opposite sign. And this is our r, and we take square root of whatever number's there. So we get r is equal to 3. Now our center is hk, which is 3, 0. And of course that's our radius. So 3, 0. It'll be right there. Radius is 3, so it goes here. And that would be our graph. Now you can test for symmetry. This is mainly if you're graphing these completely by hand, which I'll do one by hand. But we can test for symmetry with regards to the x-axis, or that's our polar axis. Replace theta by negative theta and see if you get the same equation. For the y-axis, or the line pi over 2, replace theta by pi minus theta, and you get the same equation. Now symmetry to the origin. Replace r by negative r, or theta by theta plus pi, and you get the same equation. Some of our graph forms, if you get theta equals an angle, like theta is equal to pi over 4, it's going to be line at the angle alpha, which is like pi over 4. R cosine theta, we already saw that's x, so that's x equals a number. That's a vertical line. R sine theta, we already saw that's y, so that's y is equal to a number. Take my glasses off. And that's a horizontal line. Now some other graph forms. Some of these we've seen already. If you have r is equal to a, like r is equal to 5. It's a circle of radius a. If you have plus or minus 2 times a cosine theta, then it's a circle. You see it's bordering the y-axis there. If you get r is equal to plus or minus 2 a sine theta. And now that isn't saying you're having both of those. You could have a positive 2 or negative 2 times a number. And that's bordering your x-axis. Actually, I think we looked at both of those types when we were working some problems just a little bit ago. If you have r is equal to a plus a cosine theta, or a minus a cosine theta, or sine, that's a cardioid. So the numbers are the same, a's and a's. Now here, if they're different, you got one's a and one's b, and specifically a is greater than b, then whether you got sine or cosine or use positives or negatives, it's a, hopefully I say this right, a limacon. Probably not pronounced correctly. There's a TV show on WKRP in Cincinnati. Humorous one. In one of them, Les Nessman was trying to say some sports individuals' names, and he's trying to say Rodriguez, and it was pretty humorous how he said it. Kind of reminded me of that when I probably am butchering this to no end. Now here we've got r is equal to a plus b cosine, or r is equal to a minus b cosine, same with sine, and this is a limacon with an inner loop. And we'll pretend I'm saying it right. Now here, if you got r squared is equal to a squared cosine 2 theta or sine 2 theta, that's a lemniscate. Again, hopefully I'm saying that correctly. And I know I can say this one correctly. If you got r is equal to a sine 3 theta or cosine 3 theta, that's a rose with 3 petals. If you had a 5 theta, that'd be a rose with 5 petals. So if it's an odd number, then the number you have there matches how many petals you have. Now the next one is r is equal to a sine 2 theta and r is equal to a cosine 2 theta. If you got 2 theta, you got 4 petals. If you had 4 theta, you always have twice as many, so that'd be 8 petals. So if it's an even number, it's double the number of petals than the number you have there. Now these are some of our our sum and difference formulas. We'll come back to those. We'll need them for at least this first problem. And let's take a look at this one. So identify and graph each polar equation. And let me save this, because I'll probably need some extra room. Okay. So we got 7. We got r is equal to 2 plus 2 sine theta. Let's go first identify it, and then we'll graph it. Ow. Oh. Okay. We got r is equal to 2 plus 2. None of those match. Here's some ones. 2 plus 2. This is where a's and b's aren't the same. This and this are the same, which would be this top one. So it looks like it's a cardioid. Like that. Well, that's kind of handy. You know, it's a kind of good idea to know what you're looking for before you start your graph. And let's do some symmetry tests. Although I could look at the picture there and see what it's symmetric to. Our first one says replace theta by negative theta, and you get the same equation. So this is a test for, this is symmetry. And this one is for the x-axis or the pole axis. And it says replace theta by negative theta. So we got r is equal to 2 plus 2 sine of negative theta. Well, we know that negative you can put out in front. So we got r is equal to 2 minus 2 sine theta. And there's no way I can manipulate this to get it back to the original equation. So it's not symmetric to the x-axis. Well, for the y-axis, it says you replace theta by pi minus theta. So we got r is equal to 2 plus 2 sine, and we're replacing theta with pi minus theta. Well, this is a sine of two things subtracted. I would say angles, but pi is not an angle. So if we come down to here, that's this formula right here. So sine alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. So this becomes r is equal to 2 plus 2 sine pi cosine theta minus cosine pi sine theta. Well, sine pi. Sine pi is 0, so 0 times cosine drops away. Minus cosine, so here we got a negative. Cosine pi is negative 1. Sine. Negative negative is positive, so this becomes r is equal to 2 plus 2 sine theta, which is our original equation. So it is symmetric to the y-axis. And to check the origin, let me get back up there. You can go through and try to replace r by negative r, or theta by theta plus pi, and it's not going to work. If I replace the r with a negative r, it fails. So the origin doesn't work. Okay, well that tells us something. That means it's symmetric to the y-axis, which means, as I'm drawing my picture, symmetric to the y-axis, all I have to do is get this side over here. So if I get this, then I have my graph. Okay, so we got r is equal to 2 plus 2 And let me go down to the problem. 2 plus 2 sine theta. Well, I want to choose build a t-chart, theta, and then we got r. Now this is a little bit different than before when we graphed some trig functions. You know, we went off of a period and it's pretty set in stone. Well, this one isn't so set in stone. Now I'm going to remember what a graph, what we're looking for. I'm going from up to here, so that's from 0 to pi over 2. So I'm going to get every angle going up there. So I'm going to get 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now I also probably want to get some items down here. Starting at maybe 3 pi over 2. So starting at 3 pi over 2 here, and then we want the next one here. 3 pi over 2 plus pi over 6. 10 pi over 6, 5 pi over 3. And pi over 4, 2, 3, 4, 5, 6, 7 pi over 4. And 11 pi over 6. That's probably good enough. Not much more we can do than that. So I'm going to plug those in. So I got 2 plus 2 sine 0. Sine of 0 is 0. And so 2 times 0 is 0, so that gives us 2. Here we got 2 plus 2 sine pi over 6. Pi over 6 is 1/2 times 2 is 1, so that gives us 3. And here we got 2 plus 2 sine pi over 4. Pi over 4 is square root of 2 over 2, which the 2's cancel, and we got 2 plus square root of 2, 3.4. And here we got 2 plus 2 sine of pi over 3. Pi over 3 is sine pi over 3 is square root of 3 over 2. So we got 2 plus square root of 3, 3.7. 2 plus 2 sine pi over 2. That's 1. So 1 times 2 is 2. 2 plus 2 gives us 4. Okay, so 3 pi over 2. We've got 2 plus 2 sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. Times 2 is negative 2, plus 2 is 0. 5 pi over 3. We have 2 plus 2 sine of 5 pi over 3. So that'd be... Well, let me just plug it in. 2 plus 2... Make sure I'm in radians. Yes, I am. 2 plus 2 sine of 5 pi over 3. And we get 0.267, 0.3. And 2 plus 2 sine 7 pi over 4. 2 minus 2 times square root of 2. And let me plug that in. 2 plus 2 sine 7 pi divided by 4. There we go. I knew I typed something wrong the first time. 0.6. And then 2 plus 2 sine of 11 pi over 6. 2 plus 2 sine of 11 pi over 6. 1. Yeah, I guess that makes sense. 1. Okay. We know what our graph looks like. So let's kind of see what we got so far. Okay, so 0, 2. Now 0 is not our x. This is our angle, and this is our r. So at angle 0, that's the right here, and go out a distance of 2. Which would be right there. Pi over 6, that goes out a distance of 3. Here would be a distance of 3. Pi over 6, maybe eyeballing this. Like that. Pi over 4. That's 3.4. So that'd be maybe a distance like that. I'm just guessing. I'd have to measure it to be sure. Pi over 3. Pi over 3 is about right here. 3.7. Yeah, that'd be let's say right there. And pi over 2 and 4. Would be there. Okay. And then 3 pi over 2 and 0 would be right there. 5 pi over 3 and 0.3. 5 pi over 3 and 0.3 would be maybe right there. 7 pi over 4 and 0.6. 11 pi over 6 and 1. Really kind of rough. Now remember what our cardioid looks like. Use your imagination. Oh, that's bad. And of course by symmetry it's symmetric on this side, so I know it's going to look like this. And come around like that. And it should be more of a smooth part there. I really got that screwed up. But this is what a cardioid is supposed to look like. If I'd been a little bit more precise about this, then you would have saw it. But anyway, that's as good as I'm going to get by hand. I think I did a little bit better in class. I took less data points, though, as weird as that seems. Okay, let's take a look at doing this on the calculator. First thing we have to do is put ourselves in polar form. Now I already am because I've been creating some of these for this PowerPoint. But if I press mode, you see down where it says function, PAR, POL, SEQ. You want a down arrow to that line. Then you want a right arrow and put your flashing cursor on the POL, that's polar, and then press enter. And then exit out. So do a second mode. Now to graph these, like this one here, we got 2 plus 2 sine theta. You're going to press your y equals. Clear. Put 2 plus 2 sine. Our x key, let's put theta now. Closing parentheses if you want. Then press zoom. And number 7 for z trig. And I'm looking at that. I don't see where that's any better in my graph. I think mine's perfect, but that's what it should look like. So that's our graph. Okay. Let's see. That was this one. So let's take a look at this one. Number 8. And let me save this. Go. So number 8, we have r is equal to 4 sine 3 theta. And it says identify and then graph it. It's really beneficial to you, whether you're doing it by hand, like I was trying to do, or whether you're using a graphing calculator, that you know what it looks like in general before you even begin. So you know when you've plotted enough points, when you know you got the picture you want. That's why it's important for those tables that we looked at. So let's go back up to our. There it goes. And we're looking for r is equal to 4 sine. R is equal to 4 sine 3 theta. That's going to be a rose with 3 petals. So a rose with 3 petals. I'm not going to test for symmetry because I'm just going to put this in my calculator. That was one problem, was embarrassing enough for me to do by hand. So I'm going to press y equals, press clear, and I'm going to put in 4 sine 3 theta. Close parentheses, and then I'll do zoom, and I'll choose number 7, Z-trig. And that'd be your answer. One thing I am not is a very good T-chart person. I don't plot points very well. Use calculus to come up with a graph. I can use a graphing calculator pretty good, but I don't do T-charts. I think one I was doing earlier today, I even plotted a point wrong when I put it on there. I'm just not very good at plotting points. Okay, that was number 8. So let's look at number 9. So we got r is equal to 2 cosine 2 theta. Let's go see which one this matches up with. R is equal to 2 cosine 2 theta. Here's cosine 2 theta. It says rose with 4 petals. So we're going to have a rose with 4 petals. So let's go graph this. Press my y equals, press my clear. I got 2 cosine of 2 theta, close parentheses, and then graph. And there's our 4 petals. And then we get something that looks like that. Okay, number 10. We got r squared is equal to 4 cosine of 2 theta. Now, in order to plug it into our calculator, we have to have r by itself. So you have to have r equals. Well, what we can do here is normally we'd drop our squared and we put a plus or minus square root around the other side. Like this. And we don't worry about the plus or minus. So this is just r is equal to a positive square root of 4 cosine 2 theta. Let's go see what the picture should look like, then see where to go to from there. So we have an r squared is equal to 4 cosine 2 theta. R squared. Okay, it'd be this one. So it'd be a lemniscate. So it looked like this, like an infinity symbol, kind of like. Okay. Why did I not worry about the minus? Well, we know as we do our graph, minus just flips in the other direction. So the positive will handle all of our cases for us. Now if I come here and press y equals, wait, clear the key press, and then y equals clear, do my square root, so second x squared, and then 4 cosine and 2 theta. Closing parentheses on cosine, closing parentheses on the square root. Now let me press graph. Now that would look like that's our answer. Well, that one was kind of disappointing. I wonder what the difference is. Whoa, how did my max get that big? Let me press zoom and choose Z-Trig. Okay. Well, by default, you shouldn't see that. By default, when you first come in here, it goes from theta min to theta max. Theta max is 2 pi. So I put 2 second caret, and then press graph. Now you don't have to set that. That's what yours is set to as default. And this is what you see. Well, I know what it's supposed to look like, so I know that I didn't go far enough angle-wise. And if I go to my window setting, I must have played with it on an earlier one. I see it goes from 0 to 2 pi. So I can come here and I can change that to like 4 pi. That's not nearly enough, but let me do 4 pi and then press enter. And now let me press graph. So there's that, and then it adds another little piece. And I think, okay, well that's still not enough. So I can go to window here. And instead of that, I can put in, let me put 12 pi. But 12 pi will definitely take care of it. And then enter. And then graph. There we go. And it has to do with that, how we build the T-chart and so forth. You have to have kind of an idea what it's supposed to look like before you even come in here. Otherwise, you can't actually get the graph. At first, I thought my calculator was flawed. I thought, well, this doesn't make any sense. And it still doesn't make a whole lot of sense to me because all these points should be within 0 and 2 pi. But you have to change it further. Seems like me, if I spend enough time doing it, then I should get each one of these at the different angles. So I'm not quite sure why the calculator does that. But anyway, that's what you have to do. You have to know what it looks like before you begin on your calculator. And even by hand, that one I did by hand, if I didn't know it looked like a cardioid, then I wouldn't have known it did that little twist where it's trying to go up to the origin. I'll learn to speak someday. Not now, brown cow. Isn't that like a way to enunciate better? Okay. Let me stop my recorders now. There we go. We're done with that section.